Today we have the first lesson of Unit 4, which focuses on the different sum theorems of polygons. Now, as I said in class, if you were in class, is that a polygon, again, I apologize for the calibration of the stylus, a polygon is a fancy way of saying shape. So it's a shape with three or more sides. So our first sum theorem has to do with triangles. And this is something that we've been using probably since at least 7th grade. The sum of the measures of the angles of a triangle is 180 degrees. So it's something that we've used quite a bit this year. Now we officially have it in writing. So we would say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Something that's really important to remember is that this little m here refers to measure. So we're looking at an actual degree measure. Kind of a sub-theorem is the acute angles of a right triangle are complementary. Now, if we remember, complementary means that they add to 90 degrees. So, if we know that angle 5 is 30 degrees, we know that 30 degrees and the other angle has to add up to 90. So this is kind of a shortcut for us so that we can spend less time calculating and more time actually figuring out the problem. So if 5 is 30, we know that we need 60 more to get to the 90, so that all three of these angles add up to 180 degrees. Now for focusing on our exterior angle theorem, we're looking at the measure of this angle outside of the triangle. So that's why it's exterior angle. So the measure of an exterior angle of the triangle is equal to, so that exterior angle is angle 6. So the measure of the exterior angle is equal to the sum of the measures of the two non-adjacent interior angles. So our two non-adjacent interior angles are 7 and 8. So remember, non-adjacent means that they don't touch. So 7 and 8 do not touch 6. That's why they're non-adjacent. So if we go through this theorem again, the measure of an exterior angle of the triangle is equal to the sum of the measures of the two non-adjacent interior angles. So the measure of angle 6 is equal to the measure of angle 7 plus the measure of angle 8. So now we are applying these two theorems, and we're solving for the measure of angle 1. Now, a common mistake that students make here with these problems is that they look at the 1 as a degree measure. Notice there is no degree symbol next to it, so that's how we're naming the angle. Just like we might name it X or angle A, here here we are naming it angle 1. So what I want you to do is try numbers 1 and 2 using the rules that we went over at the beginning of the notes to solve for the missing angle. So that's the measure of angle 1. Okay, so hopefully you've paused the video and you've done problems number 1 and 2. So with number 1, we're using our basic triangle sum theorem We add 21 and 39. And we get 60. Now, we know that the sum of the angles in a triangle is 180. So we subtract 60. We are left with 120 degrees. With number 2, a lot of students will do the exact same steps as number 1. However, we want to work smarter and not harder. That means that we want to look at our second part of the triangle sum theorem that tells us that the two acute angles in a right triangle are complementary, so they add up to 90. So if we already have 19 degrees, we want to find what's left. So we do 90 minus 19. We borrow. We get 71 degrees. So instead of going back and forth like we did here and here, now we just have one step. Okay, if we're looking at number 3, this now deals with our exterior angle theorem. So we're trying to find the measure of angle 1. Our exterior angle theorem told us that the measure of the exterior angle is equal to the sum of these two. Nice and simple, all we have to do, 63 plus 41 is 104 degrees. So nothing fancy there. We know that this exterior angle is equal to these guys added together. Now with 4 and 5, it's the same process. We're just using equations now. So in number 4, these three angles add up to 180 degrees. So our equation is 2x minus 5 plus 3x plus 8 plus x plus 9. And all three of those angles add up to 180 degrees. This is nothing new. We just now have a formal name for it. So what you're going to do is you are going to finish off that equation and tell me what x is. So next, if we're looking at number 5, again, we're working with our exterior angle theorem, and we know this guy equals this plus this. So that's exactly how we want to write our equation. So a way that you can visualize this is this exterior angle equals this plus this. So 3x minus 6 equals 23 plus 2x plus 1. Go ahead, solve this equation, and you are going to tell me what you get for this. So now that we've gone over our basic triangle theorems with sums, we're going to talk about the quadrilateral sum theorem. So let's see. In a convex, so that just means, a regular, basic quadrilateral that doesn't look all funky. In a convex quadrilateral, the sum of the interior angles is 360 degrees. So a lot of students, they'll think about a rectangle or a square, and they'll know right off the bat that the sum is 360 degrees. And that is the same for any quadrilateral. So what we're doing for this chart that we have down here is I'm going to show you why our quadrilaterals add up to 360 degrees. So if you take a look at just a basic quadrilateral, so for, a square, we want to pick one of the corners or one of the vertices. We are going to draw a diagonal. Pretend that's straight because my stylus is being a little difficult here. We draw a diagonal from one vertice to an opposite vertice. Notice that we can't, this wouldn't be a diagonal because it's one of the sides. Same thing with this. So what we're doing is we're looking at our square and our diagonal that we drew from vertice to opposite vertice. And we look at how many triangles it splits into. So it splits it into 2 triangles. We know each triangle has 180 degrees. Because we have 180 degrees and 180 degrees, the total is 360. So if we look at this chart, for quadrilateral, it has 4 sides, makes 2 triangles, totals 360 degrees. So if we go one step up further, for triangle, 3 sides, it makes 1 triangle, and the total is 180. So I want you to pause this video. I want you to take the shapes, split them up. Again, pretend that's a nice straight side. And you're drawing diagonals from one specific vertice or vertex to the others. Pentagon can be broken up into 3 triangles. So 5 sides, 3 triangles, 3 times 180 is going to give us 540. Okay, so go ahead and pause and finish the rest, and we'll talk about our n-sided. Okay, what I would like you to do is check what I have in this chart up against what you have. If anything is different, I want you to pause the video and change it so that you have the right values in your notes. So we're going to talk about n-sided, an n-sided polygon. So n is just a way that we represent a number of sides or a number of angles. So for number of sides, we have n. Now hopefully you were able to see a pattern from the number of sides to the number of triangles, and what we can do is we can take the number of sides and subtract 2 to see how many triangles could be made from one vertice. So we have n minus 2. Then, to get from the number of triangles to the sum of interior angles, we take the number of triangles, we multiply it. So we take the number of triangles and we multiply it by 180 degrees. So this now gives us our polygon sum theorem. So in any convex polygon with n sides, the sum of the interior angles is n minus 2 times 180. So if I was asking you the total, let's see, total in a 30gon, so that's just kind of how we say really large figures or figures with a lot of sides, is we just say they're the side total with gon. So a 30gon, so we would do 30 minus 2 times 180. So 28 times 180 gives us 5,040. So that would be the total. So now with numbers 7 and 8, what we do is, in order to solve for x, is we identify the type of shape, we take a look at our chart above, and we just find what's missing. So if we have number 7, we add up all the angles that we have. So let's see. So these 3 guys right here, we're going to add them together. We get 300. Now it's a quadrilateral, which has 360 degrees. One quick way of figuring out how many sides there are, so that you're not stuck or thinking that you're counting the same side, just count the number of angles, because no matter how many sides a shape has, it will have the same number of angles. So because there are 4 angles here, we know it has 4 sides, so this is a quadrilateral. So if we already have 300 and a quadrilateral has a total of 360, then we subtract. We see that there are 60 degrees left, and that is how much we have for x. So for number 8, you are going to do the same thing. Add up all of these guys over here. Figure out how many there should be total from the chart. And then subtract from the total to see what's left for x. Okay, please find me if you have any questions about this or if you're having trouble completing the practice worksheet.